Well, it is small. It's actually, it only weighs about 89 pounds.
Incredible.
And you can see it's about 3 feet long.
It's like 4 toasters put together.
If you put 4 toasters together, right, that would be about the size.
And this is a 1-liter engine.
Yes, it is.
And how much power is it going to generate?
Well, a 1-liter version of this engine is going to make about the same amount of power as a 2.4-liter version of today's conventional engine. So, for instance, this 1-liter, this 4 toasters, as you say, would be an engine that would power a mid-sized sedan, something like a Chevrolet Malibu or a Honda Accord.
Gotcha. So, but that engine, I mean, I've looked at it. They're as big as a dining room table.
Right.
Right?
Right. Well, there's a lot of parts in there that aren't really necessary, and that was the thrust behind the Warren engine, was to take all of the parts that are unnecessary out of the engine, and then what you were left with would obviously be the essential components of the engine.
Well, let's compare the parts. In a conventional engine, how many parts do they have?
About 300.
300. And in the Warren engine, how many parts do you have?
7.
7 parts compared with 300.
Right.
Okay, and you said this weighs 89 pounds?
Right, this weighs 89 pounds. Most of what you see here is the brackets to hold it down, the shock absorbers. So the actual engine itself is just these 2 elements here, the cylinder, and then the gear set on the back side.
Okay, and what's the weight? You said this is 89 pounds. How much is the weight of the 2.4-liter engine?
About 400 pounds.
400 pounds.
Right.
Good God, it's really remarkable.
Yes, it is. What's interesting about it is it actually, in this size, it makes more torque. I'll give you an example. To move that Chevrolet Malibu down the road at 65 miles an hour, it requires about 140 pound-feet of torque. This engine's a 1-liter. It makes that amount of torque at about 1,000 RPM. When you take that into looking at not just the weight savings, but the fuel savings that are provided, it's going to be pretty amazing.
So is it sounds like you're saying roughly double.
At least.
Okay.
Also, we don't have the RPM limitations that the current architecture has. So as an end result, you can have a 1-liter that goes all the way to 10,000 RPM. So you get a fantastic amount of power out of that. So not only is your 1-liter engine an economical engine, it's also a performance engine. Now you put those 2 together, and you've got something that consumers would actually want to buy.
Gotcha. So the size of 4 toasters, 89 pounds, 7 parts, and roughly double, if not more, the power.
I'm not sure that a toaster is an official unit of measurement. Wait, probably stick to inches. Right, okay, you go, it's that big. 2 bread boxes. Okay. Bread
Really
boxes are universal.
Really good. Is there anything that we haven't touched upon that you think is important for people to know about your engine?
No, again, I think that's, it's a quarter the size of the current architecture. Makes twice as much power at half the RPM. It's the next step in the internal combustion engine.
And it runs on gasoline.
Anything you can burn in today's engines, whether it's biodiesel or ethanol or gas or regular diesel, anything you can burn is fine.
So, and a huge gas savings, and it sounds like this doesn't need to be turbocharged. It's its own turbo power.
This one's kind of scary the way it is. I'd hate to think of it if we actually turbocharged it. I'd be concerned. So we'll leave it the way it is for right now.
Good.
Thanks.
Thanks, Jim. You're welcome.